I was recently asked on the Galaxy's Edge Discord server, would it be possible to modify a lightsaber blade from Galaxy's Edge to produce an orange blade with a purple crystal, because they preferred the sound that the lightsaber makes with a purple crystal, but they wanted an orange color. And I thought about it for a little bit and then figured out, yeah, totally possible. Wrote up some instructions and sent it off to them. And the more I thought about it, the more I thought, this is an interesting little mod, so I want to make it. So the plan is I'm going to modify my stock blade with this mod, and I'm going to do it non-destructively. And then I'm going to undo the mod and bring it back to stock configuration, just to sort of run the gamut here of making a mod, doing it in a way that you can reverse later, and then reversing it. So if anybody's interested in doing something like this, they can watch the full experience and then do it themselves. So I'm expecting this video is going to be long, boring, rambling, but if this is something, a mod that you're interested in, you can skip around to the parts that are relevant to what you're currently doing. Use it as a reference point. At least that's how I'm making sense of this video in my head. Okay, so of course the first thing we need to do is to get into the blade itself. Because this is one I haven't really taken apart a lot before, it is a little... It requires a little extra effort to pull everything apart here. Not a big deal though. Everything will come apart with just a little extra force. I promise. There. Actually, you know what? Let's talk a little theory first. You've already seen this if you've watched the previous video about doing lightsaber mods. This is the schematic for the the red, green, and blue channels on the blade, and how they're activated through these MOSFETs, and how there's this Schottky diode on the red line here, and that's bringing the voltage across the red LEDs down a couple hundred millivolts. By removing this and putting it on the green channel, you get an orange color whenever a yellow crystal is put into the lightsaber. That's because by removing this diode and patching around it with a piece of wire, the red LEDs will have a little bit of a higher voltage, more current flows through them, they're a little bit brighter. You put this over here to the green channel, it shaves off a couple hundred millivolts from the green LEDs, less voltage, less power going through them, they run a little bit dimmer. So brighter red, dimmer green, when those two are on, instead of yellow, you now get orange. So here's the mod for this particular case here. Again, we're going to remove that diode so that the red is brighter, because we want to have an orange color. But here's where things get a little bit interesting. We want orange when purple is inserted. Well, what's purple? Purple is a mixture of red and blue. So we've already got the red channel modified, and that's part of orange, so we will keep that as it is. But over here we want green to turn on. We want the green LEDs, I should say, to turn on when the blue channel is turned on by the microcontroller. So the way to do that is disconnect the blue LEDs and hook up the green LEDs through the blue channel using the diode that was removed over here from the red channel. So now when blue turns on and red turns on, when a purple crystal has been inserted, you're going to get a dimmer green and a brighter red. You're going to get orange. That's the mod. Down here I've also written up a little table here showing you what the colors for the different crystals will look like after this mod has been made. So for example, if you have a red crystal, only the red channel is on, only red will appear. If you put a green crystal in, the green channel turns on, you'll just get a green blade, same as always. But now if you put a blue crystal in, well, blue LEDs won't turn on, they're disconnected. But the green will, slightly dimmer, but you'll get a green blade with a blue crystal, with a purple. You will get an orange, again, because blue and red turn on, so the green LEDs will flow through here, the red through here. You'll get brighter red, a dimmer green through the blue channel. You'll get orange. Yellow will be yellow, and you might be thinking, won't it be orange? No, because the green channel is on, the red channel is on, the blue channel is not on, so no electricity is flowing through here. It will be just yellow, but it will be a slightly reddish or orangey yellow, again, because that diode, oops, you can't see, because that diode has been removed. But it's still yellow enough that most people will think, oh, that's yellow. And then if you plug in a white crystal, all three channels turn on. Well, what happens then? Well, because there's a little bit of a voltage drop here, electricity is actually going to want to flow through this MOSFET instead of bothering through this direction here. That's going to take an extra couple of 100 millivolts off of it. So really, that is your white crystal, which is going to, again, be just like the yellow crystal. It's going to be yellow-ish. That's the result of this mod. That's what it's going to do. Now let's get into some more practical applications. I've made some slides. I'll put it around this way. So here is the PCB, blown up a little bit so it's a little bit easier to point things out. That is the diode marked D10 here. Well, it's upside down for that. You can see D10. That is the diode from the red channel that needs to be removed and put to the green channel. Well, where are all the wires for the red, green, and blue channels? Not to worry. I've made this, which traces out or overlays the traces for the red, green, and blue channels here. So you can see the red wire comes through here, through the diode, and then of course I forgot to add this little connection here from the other end of the diode to the MOSFET that controls the red channel. Green all the way through to the green MOSFET, blue all the way through to the blue MOSFET. So we can bring back this mod here, this schematic real quick, and that MOSFET correlates to that. The green MOSFET correlates to that one. And the blue MOSFET correlates to that. That now missing diode correlates to that diode there. Yes, there are more slides. So the mod here is we remove this diode and short it out with a piece of wire. That's what the blue line here is representing. And then you also need to disconnect the blue channel from the MOSFET. There's a couple of ways you can do this. You could, say, cut the trace somewhere along here, and as long as you wire the green channel with this diode to the blue MOSFET somewhere after the trace. So if you cut the trace here, the diode would have to come over here and connect somewhere else, somewhere after here, or right to the pin. You could cut the trace, but now you're physically altering, damaging even, the PCB. And the goal for this mod is to not do that, to not damage or alter the PCB. I want to be able to reverse it back to fully stock when we're done. So the other option is to lift the pin. This is the drain pin on the blue channel MOSFET. If we lift that pin up, and then you could, if you want, put a little piece of Captain tape over the pad beneath it and then solder just to the pin. That should allow you to, that should essentially disconnect the blue LEDs from the blue MOSFET, and then you can wire the green through this diode to the blue MOSFET by wiring it to the pin and not to the pad that's underneath it. So that the final mod should look something like this. This diode is gone. It's been replaced with this piece of wire. The diode is actually now moved over here, wired up to the green channel, and then comes over to the blue MOSFET. That's the plan. That's the mod. Will it work? I have no idea. Well, it should. So let's get back into it. And the tricky part here is supporting the PCB. I'm going to try pulling the whole thing out of the tube. And that tube's going to fall over. I'll just throw it on the ground. And so this, the foam here will help support the rest of the PCB that's off to the side here while I'm down here working on this. And I can put some force on it. And it doesn't seem like it's going to bend too much. Do I have anything else to hold it in place? We'll freeform it. Why not? Alright, so step one is going to be removing that diode. So I'm going to adjust the camera so it's in a better position and get set up for that. Okay, we'll see how this goes. So what I want to do, I'm going to add some solder to either side of the diode. The first step here is just to get that diode out of here. So actually I should tin the tip of my iron real quick. That will help remove any oxides or junk from it, so heat will better flow from it to whatever I'm trying to solder. Okay, so I'm just going to put in a blob of solder here on this side, or try to anyways. Good. And I'm going to try and come in from the opposite side here. More solder. Good. So the plan now is to just go back and forth each side, reheating it until it wants to pop off. There we go. The diode has been removed. Now the next thing I want to do is I want to clean up those pads a little bit. And this part you don't have to do, but I'm going to use this as show you. This is desoldering wick. It's basically a copper braid that's stuffed full of flux. And when you heat it up and put it next to solder will flow, get sucked right up into the braid. It's like a sponge. Think of it as like a solder sponge. So if I come over here and do that, you can see it just sucks the solder right up. Gonna cut the now saturated end of that off. Finish getting the rest of that off. Solder wick you can find everywhere. Amazon, eBay, electronic stores. It's a very common item. That's good enough. Okay. How about the diode itself? There's going to be a little blob of, where's the camera? There it is. There's going to be a little blob of solder on either side here, so I'll just come in here with the soldering iron. And the soldering iron is not a solder sponge like the braid is, but a little bit of solder will come off when you wipe the soldering iron on the lead here for the diode. I just want to clean it up a little bit. It's going to make soldering things a little bit easier later. Okay. Put that off to the side. Do not lose it. We need that. Okay. Next step is going to be lifting the pin on that blue MOSFET. This is going to be the tricky part. The part that I have the least doubt about. Alright, so my first plan is to try and again flood a bunch of solder on there. And then I want to come in here with, with the solder braid, and I would like to try and just wick as much solder off of that pad as possible. The reason I put the extra solder in there is it usually helps with the solder to get it flowing. I'm just going to wait a little bit here. And that is pretty clean. Okay. How am I going to lift this up? This is the part. I'm going to try and jam these tweezers underneath. This thing isn't going to play nice with me. Alright, let's try left-handed solder iron. This feels wrong. Don't burn the foam, please. I think I got it. The whole MOSFET lifted up. Good. Sure. No problems. That is a lifted pin. Excellent. Okay. So now what? I'm going to clean this up real quick with a little bit of isopropyl alcohol and a Q-tip, and then we'll continue on. I need to cut a couple of tiny pieces of Captain tape off. This is Captain tape. You can buy this stuff on Amazon. Captain, K-A-P-T-O-N. You can buy it on Amazon, eBay. It's all over the place. It's not expensive. This is not by any means some kind of exotic material. What it is a very good insulator of heat and electricity, but mainly heat. I'm going to use this to cover a couple of pads on the PCB over here so that when I'm soldering later, I don't risk bridging or connecting to pads that I don't want to form a connection to. So I really don't need a big piece, so I'm just going to freehand this a little bit. It doesn't need to be precise. And I'll take a piece like maybe right there. Maybe right there. I'll cut a few up. Okay. Now we'll zoom in and I'll put the pieces of tape in. So in theory, it's just a matter of coming in here with the tweezers, picking up one of the cuts that I've made, those tweezers should be doing the job. What's going on? Alright, how about this one? Come on. There we go. Okay. Piece of Captain tape. Where do I want to put this? I'm going to put this over the green test pad. I feel like I need a second pair of tweezers here or something. Do I have a second pair? Sure. Oh, of course you're going to stick where I don't want you to stick. Oh, suddenly you just are all happy to stick to stuff. Oh, you suck. I know you're not even on the stupid test pad that I want you to cover. Oh, these tweezers are irritating me. Okay, so when the tweezers are not gripping the way you want them to, the drawer here is just full of tools. I'm going to use, zoom out here. Purposely bend the tips in. I suppose I could have just done that instead. Okay. Well, I'll put this on the pad underneath the MOSFET then. Again, I need a second pair of tweezers here. Just pushing the tape down to make sure it's got a relatively good connection. Now zoom in with the camera. Is that pad surrounded by Captain tape? Sure looks it. That looks good enough. Now what about the green pad? The green test pad? The blue test pad, whatever it is. That actually looks like it is covered. So maybe I'll just leave that as is. Okay, so I have placed a little bit of Captain tape underneath the, or over the pad that the blue MOSFET would normally connect to, and to the blue test pad up here, so when I solder the diode over here, I'm not making a connection here, and when I solder a piece of wire from the diode over to the drain on the blue MOSFET, I'm not making a connection here. Is Captain tape necessary? No, it just means that you can be a little less precise with your hands when soldering these tiny little components, and you have a bit of a safety net when you're sticking your soldering iron in here and trying to make connections. So next step is to wire in the diode. Here's the diode that I removed. I have cleaned it up with a little isopropyl alcohol, and if you look, you can see there are two vertical lines there on the right hand side. That marks the cathode side of the diode. That is the side that needs to connect to the blue MOSFET. The other side connects to the green channel. If you get this backwards, then you won't get orange. You will get just red when you plug in the purple crystal. So make sure you get the orientation of the diode correct. Now, one other thing that's worth talking about real quick is I'm going to put this on the PCB here. I'm going to have the anode side, the opposite end of the cathode there, the anode of the diode, wired up to the green test point like so. Now, in my previous mod, I moved this diode off to the side so I had some clearance around the edge of this hole here. I don't think I needed to do that. I think that I can do something like that and just run it like, you know, more traditional straight line to the blue MOSFET. So I'm going to try that. I think it'll fit. I'll do a test fit once I solder it in place to make sure it closes, and if not, then I'll come back in here and reconnect everything with the diode at an angle like that. But I think it doesn't matter. I think I can do it like that. So what's the next step? I'm going to put that off to the side in a safe place. I'm going to put a little flux on the green test pad there. This is quick. This is a flux pen, so it's got a little, well, now a very worn, bristly edge here, and you shake it up. You push it a couple of times to get the flux to start coming out. You can see it's leaving a little spot there. Now you just paint on it like that. The flux will help clean the pad and get the solder to flow more easily onto it. So now I'll come back down here, and I have the soldering iron tip I have here is way too big for this, so I'm just going to use a corner of it and try and get the solder to stick. It's not going to want to stick initially, but there we go. There. A fine blob of solder. Now, where did I put that diode? Apparently not in the safe place I said it was. I'm actually going to reposition the camera here. One moment. There, now there's a little more height between the PCB and the camera so I can get in here. And this might be a left-handed soldering operation. I'm right-handed. However, the orientation of the PCB is going to make it easier if I go from the left. So here we go. Will this work? I hope so. Do I chance it? You know what? That's enough. That's fine. Nope, I'm not going to leave well enough alone. Yeah, that's on there. Is that touching the red pad? It does not look it. It looks like there's good clearance there. And is how over, oh, it's off the PCB a little bit. Does that matter? Probably not. It's probably better. I don't know what I did there, but that's a real good connection. There we go, flat against the PCB. Fairly straight. That's going to run right over to here. I just need to run a little bit of wire from here, from the blue MOSFET pin to here. That should be fairly straightforward. That should be the hard part over with. Could it be? Are we moments away from a purple crystal orange blade? No, I've got like at least 10 more minutes. So here's what I'm going to try and do. I have no idea if this will work. I'm going to come over here and put flux all over that end there. And do what you're not supposed to do, which is put a blob of solder on the end of your soldering iron, like so. And bring the component to the blob. The flux sort of lets you get away with that, but not really. That's way too much solder, but you know what? I think I want more solder than I need at this point. That looks like a slightly better connection. I'm going to trim it. would try to anyways. Good. Actually, let's see how close we can get that to the MOSFET. Actually, it's right there. Excellent. A little more flux. Let me move the camera. See, if the camera's close to the PCB, the focus works better, you see more detail. But I need you a few more inches above where my working hands are. Bring you down in here. Not pretty at all, but it's a solid connection. And you can see how far off the pad that transistor is now, and that'll be fine. I should probably reflow these two pads down here, just because bending it up will have cracked the solder a little bit. So I'm going to do that real quick. Again, just a little flux. The flux will get cleaned up later with a little isopropyl alcohol. Not a big deal. You can be very judicious, or very liberal, I should say, in your application. There. Refloat those joints. Those should be a little bit better now. Okay, only one thing left to do. How much of that lead do I have left? Oh, plenty. Plenty, plenty, plenty. So I can probably take a couple millimeters off of that. I said I can probably take a couple millimeters off of that. Oh, I got the dull pointed tweezers in my hands. I want the sharp point tweezers. They grip easier on this kind of stuff. Yeah, so it'll go like that, and that'll be the connection. Alright. Now, what are the odds that that just wants to stay there and not move while I do this? I would say between 0 and 1%. Is that odd? Is that an odd? Are those odds? Are those odd odds? Come on, let's get you in there. And you're not flat against the PCB, which I would prefer. That just screws everything up. That's fine. I don't want to fiddle around with this too long. You know what, that's good enough. Okay. I'm just gonna leave everything as is. Let's package it back up. I think that should do it. Now, let's see if this fits. I said I was gonna measure this or test fit this before I did everything else, and I clearly lied, but that fits fine. Good to know. So you can definitely run that diode straight. You do not need it to be away from that hole. Okay. Now we're back to reassembly here. Nope. I have done this more times than I care to admit. Oh, shoot. But I forgot to put the tube back in, and this gets to be annoying. Okay, there. That goes on. The tube, which I threw on the floor unceremoniously not that long ago. Alright. Very careful. And you see you got big hole, little hole. Nope, big hole goes with big hole, like that. Good. Now we can put these on. There we go. Beautiful. Perfect. Turn the soldering iron off. Cap the flux pen. Cap the X-Acto knife. Extend the time that it's going to take to put this into a hilt by a good 10 seconds to torture you. And also because I need to clean off the work surface here, because I'm going to be waving around a lightsaber in a couple of moments. Will this work? I think it's going to work. Should I have thought or paid any consideration to the size of that little piece of lead that I used to connect the MOSFET to the diode, and how, is that going to be rated for the kind of current it's going to, have to deal with? Let's not worry about such things. It takes away the fun. It'll probably be fine, current-wise. I think the size of that wire is more than enough for the 250 milliamps or so that's going to run through it. Okay. Go out further. No, that's as far as it zooms out. All right. Move it up a little bit. I need a purple crystal. And these things are a pain. This cut, what I'm calling the small cut, I have the worst time trying to get these stupid things in. There we go. Oh boy, are we gonna have an orange blade? Yeah, look at that. Now, in the camera here, it's looking maybe a little on the yellow side versus me in person, but that absolutely worked fine. Let's see if I can force it to clash here. That looks like a yellow clash to me. Which works because you can still get regular yellow because the red and green channels are wired up or essentially unmodified, while the red's going to be a little bit brighter. But oh my gosh, today's just not my day. Okay, yellow kyber crystal. So this should turn on yellow. And it probably doesn't look any different to you. It probably looks still like what I said was orange. To me, yeah, to me it's a little orangey, but it's not because the red channel doesn't have the diode anymore, so it's a little bit brighter. So there's definitely an orange-ish component to it, but the purple crystal is definitely far more orangey. Just to prove a point, right? We'll do blue first, right? Blue, because blue LEDs are all disconnected now. The blue is going to be green. Yep. Maybe a little dimmer. But now you got, if you like the purple noise and you want a green, if you like the blue noise, but you want a green blade, this model will work for that as well. What else? How about just straight green? This will be going through the green channel. This won't be going through the blue channel, so it should be just normal green. In other words, a little bit brighter than the one that I just showed you with the blue. That is definitely brighter. Interesting. I believe that with this mod and the blue crystal, you'll have a green lightsaber, but it'll draw less current, so in theory the batteries will probably last an extra, I don't know, 10% maybe. What else? Red will be red. There's no point in doing that, because it'll be the same as in my previous video. White should be that orangey yellow, should be the same as a yellow crystal, except it'll be a little bit dimmer. Yeah. You know what? I think anybody looking at that is probably going to think that's orange. So I'm going to have to revise my little color table I started the video off with, and say that white gives you orange. Back to the purple. Okay, so whereas white and yellow crystals give you an orangey, an orangish yellow, there's no mistaking that. That is orange. I'm just holding it off camera here, looking it up against holding it up against the black background that I have here to judge the color. Yeah, that is orange. So, this video is already probably many minutes long, but we're not done. We have to convert it back now. Alright, time to reverse this mod. Let's get it back to stock. So I'm going to come in here. Can I get that diode up? Yes, good. And then on the right hand side, good, put that to the side. We'll need that later. With that little bit of wire. This wire doesn't want to come out. Oh, there we go. There we go. Good. Next step is to remove the Captain tape. Come on. Good. Good. And I'll just push you back down. flat against the board. Yeah, the other ones have more solder. Alright, fine. I'll put a little bit more in. I'll try and come in from this side. Good enough. Flex those and reflow them yet again because I've bent those pins a little bit. Those joints might have tiny little cracks that could create problems later on. Alright, next. Do I still have that little piece of braid, or have I thrown it away? This is the desoldering wick that I'm talking about. I want to clean the pads off of the middle there. Good. Oh, you know what? There, cleaned off the green test pad as well. Not that I had to. Okay, keep on trucking, no cutaways. I'm going to try and do this all in one go. I want a little isopropyl alcohol here because I'm not going to be able to get underneath the diode when I put it back. Come in with the other side to suck up all the isopropyl that's on there. Good. Now, we talked about the polarity of the diode and how there are lines on it. The lines should be going to the right towards that big thing here, or you could say the red MOSFET, or you could look at the picture of the diode that's underneath it, hidden away, that shows you one side of it has a vertical line, just like the diode has vertical lines on one side. Match those up. Okay. Now this diode actually already has some solder on its pad here, on its lead, so can I just use that? Yep. I need to move the camera. Camera has been moved. I want this diode flat against the PCB here. Like that, good. And then I guess I'll double check that it really is flat and that. Maybe it's flat enough. Come on. I'm holding it flat with the tweezers there. So that should be flat against the PCB. Now, have to do this left-handed, which I don't like. I'm all discombobulated here. Why won't you flow? You know why? Is that in focus? That's just bad lighting. I need flux. Alright. Alright. Left-handed Suzuki method, go. Nope. Fine, I'll just blob until something happens. Ah. There. I think I was just impatient, or I wasn't coming in at the right angle. But that should do it. That should revert us back to proper stock configuration. Take a quick look here. Alright. Just gonna clean the area up with more isopropyl. Get rid of all the flux residue so I can double check what's going on, and also probably pick up some flux residue left over from when it was originally made, because they know you're not going to see the inside of it, so they don't care about making it look clean. Look at that, like it was never touched. Okay, time for reassembly. We're not going to make the same mistake we did last time. We're going to remember that we need to have the tube in here. Whoops. Ready to go. You go like that. You go like that. Like that. And where's the hole? There we go. Good. Screwdriver. Yeah, you don't really need to see this part, do you? All right. Alright, we'll go right for a purple crystal, because that was what the mod was for. And this needs to turn on purple, and if it does, it's probably likely that we're okay. That is purple. Oh, and then another great way to test that all the channels are working is white, because if it's not white, it'll quickly tell you what channel is broken. That's interesting. I mean, I say that it's white, it's good, no problem. I saw an LED in here that was only blue for a moment. Yeah, these LEDs, some of them look like they're warm white almost, and some of them look cold white. It's nothing that I did down here. Let's just leave it as yes, this works. Oh, and let's do a yellow, because Everything that I said was yellow turned out to be an orangey yellow. Let's look at a proper yellow. Come on, get. One of these days I'll become an expert at how to put a kyber crystal into a lightsaber. Okay. Huh. Huh. I've got an LED that's got a loose something in, or rather in there. That was green. There's definitely a problematic LED in this blade. Yeah, it's green. And then it like corrects itself. So there is a bad solder joint probably for that green LED. But we'll troubleshoot that another day.